All right, so mic is working, yes, good, super. I'm Ivars, co-founder of ETGAS. The question you see here is, of course, in this case, more rhetorical one, because the answer is, spoiler alert, yes, it can be done, and we have something to do with this. So, why methanol? It's a versatile molecule used, it's a commodity, basically. 100 million tons used every day today, and used for manufacturing of everyday household tools. But the biggest opportunity is related to renewable methanol, which will deliver us a huge market opportunity, and that's why we are actually concentrating on this. And the problem is, as usual, gap between the fossil and the renewable ones. But you see the hydrogen cost, even at 3 euros per kg, the methanol cost will be 700 euros, which is still too high. But we have a realistic pathway today using waste as a feedstock. It's a negative value feedstock, which will allow us to get a highly competitive cost. And this is where our industry is going. However, there are still no operational waste to methanol plants globally. Simple reason, simple answer, lack of technology. Why we are so confident? We have spent 2 decades to validate this process, to waste conversion to synthesis gas. And now we have actually got to the point where we understand how it will work economically and feasibly. So we will convert syngas to hydrogen CO2 and synthesize to methanol. All 3 steps are validated already. We just have to build our first demo, which is the plan what we are doing already today. We plan in 2 years to have a 5,000 ton per year operational plant, and by 2030, in collaboration with our strategic and licensing partners, to have 500,000 tons of projects on our project pipeline. So who are we? We are a Latvian-based company, EBITDA generating, with a healthy project pipeline based on waste-to-power approach, and a team of 25 with competences starting from equipment design, engineering, research and development, and also project development. And we have existing manufacturing base where we produce all the hardware. So thank you.
Thank you very much, Ivar. Let's go for our 2 minutes for the jury questions.
Hi, great presentation, thanks. Lots of people want to use waste to do lots of things, like just even power plants or recycle it into plastic. Why is methanol the best use case? How do you compete with all those other people who want the feedstock?
Methanol can be used to produce plastics. So it's a full circularity. We convert plastics to methanol, and methanol is used to produce plastics. It's via olefins pathway.
So how would you say is your technology better than...
Sorry?
How would you say that is your technology better than the state of the art?
Yeah, much better. And it's working today, so we're not fantasizing. It's actually, we have UK plant in UK which is operating as we speak.
How do you solve for siting of the plants in terms of availability of feedstock?
How we solve what?
For the siting of the plant, for availability of the feedstock.
So with the feedstock availability, you mean?
No, where do you site your plants based on availability of feedstock?
Location. Okay, sorry. Location is based on where our client is, and our client is currently a waste management company. So that's the main driver of why the projects are being developed. They need to solve the waste problem, and that's is driver of our business. So waste currently is driver. In future, it will be products that will drive our business. Thank you very much.
Thank you very much. Thanks. Let's welcome on stage Miguelangel Ocando Wahban, CEO of H2 Vector. There you are. Here you are, and the stage is yours.
Hi, my name is Miguelangel Ocando, and I am the CEO and founder at H2 Vector. Let me see if this works. Yeah. At H2 Vector, we are building energy solutions in order to decarbonize applications on 3 key sectors. We are decarbonizing energy storage, heavy industry, and mobility. And we're doing it on a hardware-based hydrogen solution. Our project is ambitious, yet tackling climate change must be ambitious. We have developed our first product, a scalable and modular green hydrogen battery that captures energy surpluses, stores them, and returns them as electricity, heat, and compressed gas to support stationary and mobility applications. After surpassing the first part of our technological risk, we have been able to develop 14 projects on 4 European countries with more than 1.1 million euros in revenue. Just last year, we made €500,000 in revenues. And we're building projects in our 3 verticals. We have already built 6 projects in the energy storage space with more than 350 tons of CO2 emissions avoided, 1 project in the heavy industry space, and 2 projects on the mobility space. We have done it on a B2C approach. Starting in 2025 and moving forward, we are evolving towards an energy as a system model and on a B2B approach in partnership with Exolum in order to accelerate the decarbonization of these applications. We are raising our seed round. We have already secured 70% of our ticket, and we're looking for investors that help us to build the foundation on this as a service model, as well as to develop key R&D projects that will enable us to grow faster. If you are an investor that is looking to build an impact and tackle climate change and build a new energy model based on a sustainable and resilient approach, I'll be happy to have a chat and discuss further. Thank you.
Thank you very much. Let's start with the 2 minutes questions. You are 20 seconds ahead, so we will add those 20 seconds for the jury questions.
Thank you. I was wondering, what's the rationale behind, you said you're moving from a B2C to a B2B approach with a partner. I mean, you seem to have decent traction with the current projects you named of 14 with your current approach. Why go towards B2B?
Well, we have traction, we have customers and validation with the B2C approach, but we see that in order to scale our growth, to move forward, to have a better and a higher impact, moving to a B2B and especially to an energy as a service approach will help us to build a pipeline that will enable us to grow faster and to tackle CO2 faster.
Thank you.
Can you talk about the round-trip efficiency of the battery?
I love this question. It's always asked. We can talk about 3 types of efficiency in this case. Electrical efficiency, we are less efficient than a lithium battery on the short term. When we talk about global efficiency, handling electricity and heat, in terms of energy, we could be compared to a lithium battery. We can have more than 90% of efficiency with our hydrogen batteries. And the 3rd type of efficiency that I'd like to discuss, and I love this question, is that we can abate CO2. Let's say we can cut CO2 on the scope 3 by half of the equivalent lithium system.
Got it, thanks.
What's the main use case? Is it for like short duration storage or like seasonal? Like what do you see the most value for the customer?
Seasonal, it's a shorter, if you have a short-term storage, which is, let's say, 3-6 hours, now you need to stay with lithium batteries because we scale nicely when we have when we need an energy autonomy of 24 hours or more. So, and in terms of long-term storage or seasonal one, in order to build the storage part, it's way too capex intensive. So the sweet spot, it's 24 hours or more, and combining it also with a hydrogen production for scaling it up and to have like a mix of combined businesses around.
Okay, thanks.
Thank you.
Thank you very much. We run out of time. Okay, thanks. Thanks, Miguelangel. Let's move on and let's welcome Carlos Sanz Senon, Corporate Development Director at Matteco, on stage. Here you are.
Thank you.
Good luck.
Thank you. So we are Matteco. We like to say that we are a clean tech company. Our mission is to decarbonize the economy through new materials. Our short-term goal is make green hydrogen affordable. Our materials are the magic behind alkaline and AM electrolysis. Today we have in the market the anode, which today is being integrated with different clients. Those clients are guaranteeing us revenues in the size of 100 million in the following years. And the cathode, which is at a lower TRL, but is backed up by the AEC transition program, which is helping us to move fast. Why we have started by green hydrogen? We have started by green hydrogen because it's the application with a more direct impact in our mission, decarbonizing the economy. And second, because in today's fragmented world, green hydrogen will have a critical role in getting energy independence in regions like Europe, which are it's a critical part today. Of course, we have huge challenge in front of us. Everyone, when we speak about green hydrogen, everyone will speak about cost. So we do need to innovate all the way the value chain, the green hydrogen, and is where Matteco focus. Matteco focus on innovation in the production process. We have approved savings on around 20% of the LCOH, which is translated to around 20 million euros cost savings in hydrogen plant. And second, last but not least, our PGM-free materials give us some lever as well on those energy dependency that is becoming that critical. If we want to be energy independent, we cannot rely on materials coming from Russia, China, or the US. Our aim is to move fast, to move really fast, so that's why in the last couple of years we have focused on bridging the gap between the lab and the industry. Today we can say that we have full industrial capacity in Valencia, and we have developed customer-centric solutions in terms of sizes, formats, and substrates. But of course, the journey has been long. Everything started 15 years ago at the University of Valencia. We are a spin-off of the University of Valencia. But in 2023, the university wanted to reach the market with those state-of-the-art materials, and Matteco was born. Last year was a very important year for us. We raised our 15 million Series E and got different awards that are pointing at a very bright future in which we will continue developing applications not only in hydrogen but also in water purification and others. We have 40 people, and we are led by Iker Markaide, a serial entrepreneur with more than 10 companies founded. Today, one of his companies is listed in the Nasdaq, and Gonzalo Bañán, a well-known scientific with several awards such as Marie Curie's and ERC's. So thank you. We hope you want to join us in developing new materials for a better world.
Thank you very much. Let's start the 2 minutes question.
Thanks for the presentation. Is the revenue model to design new materials and then build factories that sell them, or is it to license the new materials to people who will manufacture them?
We are doing it ourselves. So the manufacturing facility is operated by ourselves. So part of our IP, so we have 2 patents filed. One is the catalyst, the powder, and then the process, which is our process as well.
So I have a question about the sales journey, sales cycles. How do you get to your customers? How do you prove? How do you how do they validate your product? What is the process like?
Yeah, that's a great question. So our funnel starts, of course, with small samples. So they test our products in lab scale. Then we move to what we call pilot stacks between 10 and 50K. 50K, and then we moved to real stack sizes between 50K and 2.5 megawatts. We have clients in all the stages. We have 50 clients that have paid for our samples, and we have we have 6 clients testing in real conditions.
Forty seconds. Any more questions?
Thanks. Between the different types of electrolyzers, which electrolyzer technology do you see the most added value for your materials?
So today, alkaline is more mature. It's still a baby. So our material has proved the better efficiency in the market for IM, but it is still a baby. So we don't have real electrolyzers operating in IM. So we are pushing more for alkaline because it's already in the market. And we don't say that we will not go to PEM or other technologies in the future.
Okay. Now we've run out of time. Thank you very much. Okay, let's move on and let's welcome Saurabh Kapoor, CEO of Metafuels, on stage. Welcome. Here you are.
Excellent. So, good afternoon, everybody. Happy to be here. SAF is key to decarbonization of aviation, and there is an urgent need for significant quantities. Can you help me with which button? This one. Yeah, sorry about it. Significant quantities of sustainable aviation fuel, but at affordable prices. At Metafuels, we are making it happen. With our best-in-class aerobrew technology, we are able to reach lowest cost of production when we talk about eSAF. And not just that, plants implementing our technology can interchangeably produce eSAF as well as biosAF, depending on the feedstock that's deployed. Where do we stand on our journey? We currently have a pilot plant in operation in Switzerland. This pilot plant deploys our core innovation, and with each locked hour, we are basically significantly de-risking our technology. We are also just a month away from commencement of commissioning of our tank-to-tank demonstration project. By tank-to-tank, I mean starting with a tank of methanol and ending with a tank of jet fuel. This unit not only implements the core innovation that's in the pilot plant, but more importantly, the configuration is similar to what we are going to build out in the field. So what we're going to talk about from this point onwards is really scaling out and scaling up. Lastly, in parallel to these tech activities, we are busy developing a pipeline of pioneer and scale-up projects. Our flagship project would be at the port of Rotterdam in Netherlands at a 10 tons per day scale. FID on this project is planned for middle of next year, with production commencing mid-28, in time for the step change in European SAF mandate, going from 2% today to 6%. Very likely also going to be the first methanol to jet capacity to enter into production worldwide. Meet the team that's making it happen. We have a lot of industrial experience. So my team members and myself, we have worked in energy, oil and gas, hydrocarbon technology supply, sectors before. We have developed technologies, we have scaled up technologies. We have also developed in-house, first-of-a-kind demo projects, large demo projects, multi-million kind of projects. The advantage that this thing gives to us is basically that know-how is in-house, makes our processes very efficient, and also when we talk to established players in the industries, we come from a position of strength because these topics are known. It's also clearly demonstrated by the fact that we have achieved all this progress in a little over 2 years, starting with our first venture round in January 2023, and with very high capital efficiency. We have just raised $17 million. Not raising money at the moment, but do plan to raise money this summer. So if the topic is of interest, please do come find me and talk to me. Thank you.
Thank you very much. Let's go for the questions.
So what is the production that you can expect from your factories?
Production
capacity.
So the first big projects are 10 tons per day, but we are doing two developments at the same site in Rotterdam, a 10 ton per day, followed by a 100 ton per day SAF project. And this is SAF capacity. This is not general crude or e-fuel capacity. We produce very little quantity of byproducts.
did you say you had offtakes or?
So we are currently in the process of finalizing offtakes with some leading European airlines. Next couple of days, certainly within this month, we will have heads of terms agreed. So the project FID is still 1 year away, and we need to mature all work streams jointly. We have heads of terms for methanol supply agreed, heads of terms shortly for SAF, and we have to just progress engineering and other activities because these are all interlinked.
Hi, how's your production cost compared to other, more mature production pathways? Alcohol to jet.
So I think our starting premise has been the future of e-fuels as well as biofuels would be dominated by aviation and less by terrestrial transport. So we are really making sure that valuable carbon, valuable hydrogen ends up in SAF. So when you talk to FT, and I mean more EFT technologies, our cost of production is half of what's achievable with FT. If you talk about like electrolyzers of today and value chains of today and project it to our 4th, 5th, 6th project, we are aiming to be at the lower end of what's achievable with HEFA today.
25 seconds.
Last one fact, we are the only methanol to jet startup worldwide. Giving us company are only the big boys. Okay.
15 seconds. Any more questions?
There must be some. No.
Okay, thank you very
Thank
much.
you so much.
Let's welcome Andris Krasovskis, Chief Financial Officer at Naco Technologies SIA. Welcome.
You pronounced my name, that's cool. So, hi, I'm Andris, CFO of Naco Technologies, and at Naco we're tackling one of the most pressing problems in transitioning from the fossil fuels to green energy, and that is reliance on critical materials. With the push for green energy in general globally, the demand for materials is expected to double during the next 10 years. And even materials which are currently considered non-critical will face shortages that will lead to skyrocketing prices and jeopardizing the whole progress. So here, we as Naco step in and we help in 2 ways. First, we develop novel nanomaterials in the form of nano coatings, and in order to do that, we can combine any material from the periodic table. And secondly, we nanocoat components that you would find in the energy systems by improving their performance, durability, while also reducing the usage of the critical materials by 10 times. In fact, in a recent study that we did together with Herrmann's company, we have shown that we can reduce catalytic material by 40 times, 40, that's huge. And all this without affecting the efficiency of the system. So the technology that we are using is called high-speed magnetron spattering, and it revolutionizes the coating industry by combining the superior quality of ALD, methods like ALD and PVD, with the efficiency and scalability of the methods like electroplating. And it does it in a most sustainable way. The technology uses physical processes instead of chemical reactions, and this doesn't require as much energy and avoids usage of water or hazardous chemicals at all. So you could see our technology working already in electrolyzers in the fuel cells, where we cooperate with around 30 different clients, some of them one of the largest names in the hydrogen industry, but we're also looking into other applications like chemical reactor electrodes or exhaust system catalysts. Last year, in our home base in Riga, Latvia, we have launched our pilot mass production line that is capable of coating 500,000 components per annum. And with this, we are transitioning from the pure R&D into a production company with coating provided as a service. The next step for us is building production units closer to our clients. And with the next one, large-scale, highly automated production facility to be located in Poland. And in order to make that happen, we are currently launching a Series A round where we want to raise 10 million euros in addition to 6 million euro local grant that we're currently in the process of obtaining. So I invite you to join us in our journey of empowering the green energy transition. Thank you.
Okay, let's go for the questions.
Thanks for the presentation. Just to clarify, have you designed new materials or is it a new material coating technique?
It's both. The technique itself, it's PVD, magnetron sputtering. It has been around for some time. What we have done is we increased the speed of this process 10 times. And this also allows us to combine different kinds of materials to come up with the new composites that would give new kind of features.
And is there any trade-off in doing this versus traditional methods?
Well, as I mentioned, the PVD method is one of the most qualitative ones. But usually now it's typically very high cost and it's very niche application. So what we have done is actually make it affordable and make it kind of scalable and efficient.
What's the net cost gain or performance gain for a typical application of your product?
So if we would take, for example, PEM electrolyzer, so the catalyst coating would take around 25 to 30% of the total cost. So imagine that we can reduce 40 times the amount of the material used. So that gives you the rough idea.
Okay, so around like 20-25% cost decrease because of that.
For the stack, it's like that, yes. But of course, you need, if we talk about the whole hydrogen, whole cost of hydrogen, there is also balance of plant. So, okay. Yeah.
Is there any limitations on any parameters, like size, throughput, or whatever?
Sorry, could you repeat, please?
Is there any limitations on some metrics, important metrics like size, throughput?
Yeah, at the moment we are able to coat flat surfaces. We are working as a next step for roll-to-roll technology. So currently it's flat surfaces, sheets like that. We are, with the current pilot plant, we are limited to 40 by 40 centimeters. But with the next plant, we will be able to cater to basically all the sizes of the components that are currently on the market.
Okay.
Thank you very much.
That's all. Thank you very much. Thanks. Okay, let's welcome Francesco Maria Benedetti, co-founder and CEO of Osmoses, on stage. Here you are.
Thank you.
Good luck.
All right, wonderful. Thanks, everyone. Hi, my name is Francesco, CEO and co-founder at Osmoses. We're a clean tech company based in Cambridge, Massachusetts, where we are transforming molecular separations. And why this matters is because the cost of unmixing, separating, and purifying molecules is massive, both for the industry and for the environment. We're talking about 15% of the world energy and carbon emissions that depend on thermal processes that are used to run separations that really power energy, petrochemical, and chemical industry. So we made our mission at Osmoses to rebuild this industrial infrastructure where separations are not a bottleneck to a cleaner future anymore. We're doing so by commercializing breakthrough science. We invented a family of ladder polymer materials that when manufactured into membrane technologies, very thin films, they leave behind porosity, which size is very similar to that of gas molecules, the smallest molecules on Earth. And we can separate them very effectively based on size without the thermal component that leads to high energy consumption. We're backed with by great venture capital firms, government agencies, and nonprofits as well. There's a lot of gas molecules, so where are we going to start? Our favorites are hydrogen and biogas in terms of low carbon molecules because of their potential in decarbonizing the heavy industries, and also because reducing the cost of separation can really unlock their potential, but also helium because it can power the AI revolution with the semiconductor industry. But this is just the beginning because we have a platform technology that can serve multiple verticals of the energy transition, which is already today a $15 billion market in sales of equipment, projected to grow beyond $35 billion by 2030, which also comes with a significant impact on sustainability. In fact, in the next few years, just with our installation, we can reduce tens of megatons of CO2 emissions. Our product is a membrane module. That's where our expertise are. We talk directly and communicate with end users, understand their pain points, the opportunity, design solutions that we build to our engineering partners to build, and membrane systems are eventually delivered to end users, which is the fastest go-to-market strategy for us. Our founding team came together back in 2021 with technical background from Stanford and MIT. We grew our team to more than 20 people, bringing together a wealth of experience also from industry, and we're scaling our commercial operations today. We spent the last couple of years scaling up our membranes, building prototypes, enhancing our partnership with companies, and raising 2 rounds of financings that projected us to build towards piloting with customers, expanding our customer pipeline. And last year, we closed with the first $1 million revenue coming with a combination of project with customers and government contracts. We signed our first 2 pilot agreements that are going to be in the field in 2026. And also, we received a very competitive ARPA-E Vision Open grant that has been very satisfying. All of that to launch us to commercialize in 2027. So I hope you're going to join us where the smallest molecules meet the biggest opportunities in the energy transition. Thank you so much.
So, one a bit technical. So, what is the conditions of the syngas that you feel more comfortable with? So, what is the gases that you like the most?
Yeah. So, the most of our traction today comes from the biogas world. So, basically means it's a mixture that is mostly CO2 and methane, with some components like H2S, siloxanes, and other gases you don't want. The goal is to separate CO2, H2S, and siloxanes out of the mixture to purify methane. So that is one of the applications that we're after. And the reason why we're very excited about that, because it's a fast market. The customer base is pretty fast, and it's helping us to get 2 contracts faster that we can use to raise our next round of financing and really establishing our commercial partnership faster.
Great presentation. Can you explain a bit how you're working with the engineering partners exactly? So they develop gas separation technologies and they just switch your product for what they were using before? Like, how does it work?
Absolutely. So we focus on the membrane module, which is where our innovation is and where also our margins are bigger. We like to partner with an engineering company that brings the engineering expertise and builds around our membrane module with things like compressors, piping, valves, etc. And they package the solution as an OEM to then deliver this to the end user. Or if we work with chemical and petrochemical large companies, this is generally an EPC or another organization that is connected with them that we're working with.
Can you selectively separate gases now?
Sorry?
Can you selectively separate the gases?
Yeah, exactly. So this selectivity is based on size. This is also a unique characteristic of our membranes because we managed to crack the code on the polymer design so that we can design polymers so that we can leverage the smallest sub-angstrom differences in the size of gas molecules and separate them, for instance, hydrogen and other molecules, yeah.
Sorry, with the biogas, are you producing a pure stream of biogas? Like, where does the CO2 and the sulfur go? Is it stuck in the membrane? How does it get disposed of?
That's a very good question. So, like, we capture CO2, we separate CO2 and other gases, so we basically make a stream of methane that is 98+% pure. And the gases actually don't get stuck in the membranes. It doesn't work as an absorbent, so we don't need to regenerate the membranes. The membrane is a passive barrier through which the gas passes, and they are accumulated in another vessel.
Thank you very much, but we ran out of time. Thanks. Thank you, Francesco.
Thank you.
Big applause. Okay, and next on stage is Andrew Symes, CEO of OXCCU. Welcome back on stage, Andrew.
Thank you. Hello, hi everyone. My name is Andrew Symes. I'm CEO and founder of a company called OXCCU, and we're focused on making sustainable aviation fuel. This is us in one slide. We've got 22 people now. We're an IP-driven company, and we're on a pathway now to essentially deliver economic SAF in time for the mandate, which is around the end of this decade. Why is that important? We currently make 0.1 billion litres of SAF. It's all from vegetable oil, and we need to make roughly 450 billion by 2050. It's an enormous challenge. In order to do that, we have to use CO2 and waste biomass, and we have to use SAF because ultimately if you want to travel long distances on an aeroplane, it's got to be a hydrocarbon. There's real mandates now in the EU and the UK that commit us to producing a certain amount of SAF, and there is some big money going in some very large investment rounds. But there's a challenge. The challenge is cost. Everyone knows it. There's 2 reasons for that. The first is a high capital cost because you've got multiple steps in the process. And the second is a high operating cost because the energy input, often to make the hydrogen, but also because of selectivity. The solution is our process that essentially simplifies the process of turning CO2 and hydrogen, or CO2 and hydrogen, into fuel by essentially reducing the number of steps, so less capex, but also reducing the OPEX by essentially with a more selective process that can drive the maximum amount of expensive hydrogen into the jet fuel, which is what you want, and not into other byproducts. This is our journey. We started a long time ago. Tianken in the University of Oxford Chemistry Department has been working in Fischer-Tropsch his whole career. This research around the INFT catalyst that we have started around 2010. In 2021, we spun the company out. We raised our seed round. In 2023, we raised our Series A. With that, we built our demonstrator, and we're now essentially raising our Series B, which will be to make a fully integrated, small-scale demonstration plant of our full process. This was our Series A. We're backed by some of the best people in the existing industry today, and they're all excited by the potential for our technology to get costs down. This is our demonstration plant. We built this in 15 months, on time, on budget, in Oxford Airport. This is what we delivered after our Series A, and we'll do the same now after our Series B. We'll do a bigger plant that will be fully integrated, make the finished jet fuel. And again, all about reducing the cost of making it. So essentially, this is our plan. This is what we're going to do. OX1 demonstrated the catalyst at 1,000 times the scale of the lab. OX2, which is our next demonstration plant, that will be a fully integrated demonstration of our technology. OX3 will be our commercial plant, which we plan to have in operation by the end of this decade. Thank you very much.
Thank you, Andrew.
Questions?
Let's go for the questions.
Thanks for the presentation. Is this a separate pathway that needs to be like ASTM certified to like methanol to jet FT?
It's a Fischer-Tropsch pathway.
Okay.
So yeah, but the conventional Fischer-Tropsch generally doesn't work with CO2. So cobalt FT is generally deactivated by CO2. We're iron-based FT, but iron-based FT is already approved as a Fischer-Tropsch pathway. You can have cobalt or iron.
Great presentation. How much of the total cost of your final SAF product is the cost of hydrogen, and how does that differ with competitors?
It is massive. For e-fuels, it's massive. Obviously, if you do biogas or gasification, it's less. But 50–60% of the cost of all e-fuels can be, the hydrogen. But the hydrogen efficiency of your process matters hugely. So it's not just about the electrolyzer and the electricity that goes into the electrolyzer. It's around your hydrogen efficiency. So how many tons of SAF do you produce per ton of hydrogen? Because if lots of your hydrogen goes into other byproducts or you burn it, that has a massive effect on your economics. So yes, hydrogen is dominant, but it doesn't mean that it only matters essentially what your hydrogen cost is coming in. It matters how you use it as well.
And on that, you're much better than competition.
You have to be, yeah. And that's, when we talk about our process, but yes, we've got a 50% capex reduction. We've also got the OPEX reduction as well, which is critical because it's an OPEX-driven process.
Any more questions? We still have a few seconds.
All good.
You explained it very well.
Thank you very much. Appreciate it.
Thank you very much, Andrew. Okay, let's move on and let's go with our final and last but not least speaker on stage for this track, Stephan, Herrmann, CEO and co-founder of Reverion. Welcome on stage. 3 minutes to go.
Thanks a lot. I am Stephan from Reverion, where we are making the ultimate power plant. So building out a lot of wind and solar helps greening the power grids, but it also causes some problems that you can see here. Sometimes there's way too much power, sometimes there's not enough power. So blue and red. And now you can start building batteries to kind of compensate for that. And you can do so in summer, but you will have a hard time in winter, because here you can see there's a 3-week period of constant overproduction. You cannot solve that with batteries. You need electrolyzers to use that power. On the other end, you have this period where there's 2 weeks no power. You cannot solve that with batteries. You need some power plants to back up that. And so you build up a lot of things that are useless a lot of the time. Or you build Reverion power plants that are the most efficient power plants in the world. And they are reversible, so you can use them in both times. Additionally, they are plug-and-play container-based solutions and also can capture CO2 as a side effect of our process. We connect those power plants to biogas installations. It's a brownfield retrofit solution that enables biogas plants to actually become the energy hub of the future by leveraging the power of the gas, essentially make more power when it's needed, and also operate in reverse, so take power from the grid to make green molecules like hydrogen or methane when there is too much power on the grid. For our customers, this essentially means that they transition from a combustion-based process with combustion engines earning from just electricity into a revenue stacking where, first of all, they earn more from power, but secondly, they can now profit also from the reverse process. That means they can use excess power from the grid to make green molecules like hydrogen and methane when they would normally not earn anything because there's too much green power on the grid anyway. So biogas is our first market, our first product, but we can also step outside of that. We, for example, are opening a second product line that will only operate on hydrogen, meaning it can use hydrogen to make power, but it can also make hydrogen from excess power in reverse, and thereby use it as energy storage. And because we are very efficient, we can reach a round-trip efficiency of up to 75% for this storage, getting close to the traditional pumped hydro and similar solutions. Combining all of this together actually allows us to solve the whole energy transition with this one solution that is kind of replacing all the existing solutions that only matter part of the time. We closed our Series A last year, and we're operating off that, right? So we're not fundraising at the moment, but of course, I'm happy to talk for future fundraising next year. This is our team. We're still scaling up and to fulfill our mission to essentially power the whole energy transition finally on a green power. Thank you.
Great presentation. For the biogas producer, what's the alternative they have? Are you competing with biomethane upgrading or just them to make electricity the conventional way? Like, who are you competing with for biogas?
Yeah, there's actually these two options. Most of them are just burning the gas in a combustion engine to make power. The second option is to upgrade into biomethane, where you separate CO2 and methane, feed the methane to the grid. We're essentially allowed to combine the two, make power from the biogas, essentially also capture CO2 as a side effect of it, which is kind of new. And then you get the alternative way where you actually feed the methane to the grid, but now also the CO2 part is actually upgraded into methane as well during the electrolysis. So we can actually allow to feed twice as much methane to the grid as well.
Could you tell us a bit more about the traction? How many units are operational or installed? What's the pipeline looking like? That would be great.
Yeah, we just installed the second unit earlier this month, and we're going to install the third unit end of this month, and we're going to build more. But we're currently constrained in manufacturing, which we are building out now. We just received a grant from the Innovation Fund, almost 20 million to scale manufacturing capacity. So we're on that, and the units out there are running well. So
thanks.
What happens to all the byproducts? So if this is happening like at a really decentralized level, does every farm need a CO2 pipeline and a hydrogen pipeline, or do you keep it on the farm?
Well, the network the grid is of course a topic. So almost all customers now want methane injection to the grid, not hydrogen, because grid is not hydrogen ready. But it will probably transition into hydrogen over time. So then the customers can transition with it. which is an advantage compared to biogas upgrading, because then you're stuck with the methane. So they don't need like this logistic for the fuel gas. Hydrogen, the CO2, of course, you can liquefy on site and you can pick it up with a truck. It adds, of course, some logistics costs, but the CO2 essentially comes out for free. So there's a huge benefit as well.
Thank you very much. Okay,